Okay. How you doing?
Great. How are you?
Good, thank you. Let me take a quick second to pause, try and reaffirm. If you're struggling, you are one of millions of calculus students to struggle with trying to get used to what is all this stuff about. If it's not quite there, then you are exactly where you're supposed to be. And if you're not quite sure what the heck is going on, me either, when I was in your shoes, I didn't know what the heck. Okay, what slope, derivative, I don't, whatever. Just keep going, and it'll start to all make sense. I promise you. It doesn't have to make sense now. It has to make sense May 15th. All right, or whatever the date of the AP exam is. Okay. Until then, struggle. Just struggle. Okay. So, towards more struggle. Are you ready to struggle some more? Yeah, struggling is what builds up your muscles, right? Makes you a better player playing against superior competition. So, I'm taking a little bit of liberty as far as combining sets here. I need to really, besides being true to the book, I also need to make sure you understand copy. It's more important. So you'll find that tonight's homework is actually a little bit of a mixture of set 20 and 21. What I'm about to teach is actually not in either of those sets. It's later, which is crazy. But the homework problems are from the book set 20 and 21, so be careful that you're in the right set tonight when you do your homework, okay? Okay, here we go. This homework is derivatives, or these notes are derivatives, that's why it's yellow. And it occurred to me that I screwed up my color copies for BC. Yellow is derivatives, right? Yeah, right. Were yesterday's notes yellow?
Yep.
And were the limits green?
Yeah.
Oh, I screwed up A, B, or BC already. Oh well. All right. So this would be chapter 2 in most calc texts, and this would be one of the first sections, definitions of the derivative. Now, as if the first definition of the derivative wasn't enough to confuse you, now I'm going to throw 2 more at you. Sound good? The good news is that there are only 3. So by the time I'm done, you will be having seen all of it. The symbols, the notation, they're different. That's what makes them different. The idea is 100% the same. The 2 big ideas of the derivative are slope through 2 points, move the 2 points together to approach slope at 1 point. That is what a derivative really is. Slope between 2 points, approaching slope at a point. Are we cool? How do we get the 2 points close together? Take a limit. Thank you very much. At least one person is understanding. So far, so good. All right. Now, this right here, what I'm about to cover, is typically called the first definition of the derivative, or the definition of the derivative. It's what we did yesterday. So just by way of review, we actually looked at 2 cases. When we first introduced this, I talked about what if you want the slope particularly at some number, 3, 5. A is a number, all right? We created another point like it, and we tried to draw the slope between them, and then we got the points close together. Now this is used to find slope at A in particular. Not any old x. It's not meant to yield a slope rule for any x. It's meant to be the slope at that point, whatever I chose. Okay, so at the end of the day, if I said, hey, what's the slope at 2, would it be an actual number or some kind of rule that could be lots of things? A number or a rule? A number, okay. When I say what's the slope at this point, it would just be one thing. It wouldn't be lots of things. There would just be one slope at a particular point. All right? Slope at A. Or I should say x equals A, so it doesn't look like slope out. Okay. Now the points we're going to use, obviously there's A, F at A. Or maybe that's obvious. Now, the idea yesterday we talked about is you make a new point by going h over. So if you start at a, go over h, that puts you at an ending x value of a plus h. So the other point would be that a plus h, and then the y value would be whatever you get when you put that into the function, and it would depend on what the function is. You follow? Now then, the slope would be the change in y, f at a plus h, minus f at a, over the change in x. A plus h minus a is h. Now, what does that represent I just wrote? Difference quotient. I love it. Thank you. Difference quotient. Visually, it's the, graphically, slope. Slope of the tangent or slope of the secant? What is the difference between a secant slope and a tangent slope? Secant is between 2 points, and a tangent is at 1. So right now, it's the slope between 2 points. To get the points closer together, I'm going to move one of the points. Now, A is set in stone. You know, it's A, it's 3, whatever. It doesn't move. What moves is A plus H. By taking this gap between them down to nothing, I start to get slope closer and closer and closer to at A. And I do that by virtue of a limit. The limit as what goes to where? H goes to nothing of that slope or difference quotient. Now, in terms of notation, let's use Newton's notation. This is f prime at, is it f prime at any x or at a particular point? It's at A. That's f prime at A, or the derivative at A would be the result of what comes out of that. That's what we did yesterday, or one of the two things we did yesterday. Does that look somebody familiar? Okay. Now let's take a look at also something we said. Remember, we then talked about, well, if I then said, what's the derivative at 3 and 5 and 7 and 9, that would mean a lot of separate calculations, and that would be a drag. So instead, then you sometimes want a rule that would give you the derivative at any x. Now, if that's the case, then you're really going to say, let x be any old point. And I put it there, but it could be here. It doesn't really matter. And so you're going to find the slope at any x. Now, just like before, it takes 2 to tango. So besides x and f of x, that first point you're interested in, you're going to need to create a second point. But it's the same concept. You go over a little bit, which we'll call h, although a lot of books call it delta x, change x a little bit. I just use h because it's less writing. X plus h, and it's h is used in a lot of textbooks, too, don't get me wrong. So I'm going to go over h to get a new point that starts at x and goes over h, so ends at x plus h. That means the point would be x plus h and f at that point, right? The difference quotient, or the slope between those 2 points, would be f at x plus h minus f at x. If you are saying stuff right now, thank you for participating and making the class go better. What about the difference in x? H, beautiful. Okay, x plus h minus x, you get an h. In this case, to get the 2 points close together, what do? Take h to 0. It's the same idea. You're taking the gap to 0, and f of x plus h minus f of x. You're keeping the same slope idea. The difference in notation would be, that would be finding f prime at x, any point, not a, at some x. Are you with me? ¿Entienden ustedes? Or is it comprenden? Is it comprenden or entienden? Is it? Okay, I can never remember the distinction between the two. It's been 25 years since I did my Spanish. Okay, now, getting into the new ones then, please keep in mind, although they may look different, the concept is the same. At the heart is the same idea, okay? So the alternate definition would be used to find the slope at a particular point A. So it's often used in the same kind of wanted at a certain point case as this one. So let's say I let this be A, right? Now this then would indicate that one of the points is A, F at A, yeah? Now what makes this a little different is how they get the second point. Rather than say H over, I'm gonna, and call this A plus H, I'm just gonna call this second point X, because it could be lots of stuff, and it can move, it can vary. A is a constant, so it is what it is, but X can be, 3, 2, 1, and so on, so I can move it. That would mean that the other point is X, F of X. And if you're really starting to understand this idea, you should be able to tell me what the slope would be between those 2 points. What is it? Beautiful. F of X minus F at A over X minus A. Nice. All right. Now that's good. Now if you really know your stuff, you know what to take the limit of. Now the idea is to get the 2 points together. What limit would you do to get the points together? Would you take A to X or X to A? Yeah, X to, actually, yeah, X to A, yeah? Now, some people say X to 0. Do I want to take X to 0? No, then I would have the slope between 2 points that are not necessarily X. You want to take X towards A. So, as many of you said, take X to A. And by virtue of doing that, the gap would get smaller and smaller. This, notation-wise, what am I finding? F prime at A. That's the derivative at specifically A. Okay? Now, you would see that happen and get a numerical answer by doing the limit. You'll see how that goes. All right. Last but not least, symmetric definition. Say you wanted the slope. This could actually be used at any point or at a specific, or at a general point X. Let's do it in the X style, okay? Now, this one's a little different in that I want the slope at this point, yeah, the tangent slope. That's not different, actually, that's what we always want. This one's different in that rather than use the point you want and another point, you're actually not going to even use the point you want. Now that seems crazy, but you're going to go a little gap above to get a new point, which would be X plus H. You're going to use that point. And for your second point, you're going to go that same H below. Think symmetry, symmetric. They don't call it symmetric for no reason. It's symmetric because it's the same on both sides of the point you want. So you're going to go H below, or negative H below X, which would put you here. That's X minus H. Now the slope then would actually not even include the point you want. But think about that. Now in this case, you're not going to move 1 point. You're going to move 2. You're going to, as H gets smaller, both of these points move, and you get this slope. And then if they get smaller again, you get this slope. And then if you get smaller again, you get this slope. So by moving both, you center in on the point you want, and you start to get the tangent slope, you see? So it's moving twice over. What are the points? X plus H, F of X plus H, and what's the lower? X minus H, F at X minus H. Right? The slope then would be, it's arbitrary, which remember slope, as long as you stay consistent, it doesn't matter which you call first and second. So I'm going to go F of X plus H minus F of X minus H over change in X. What's X plus H? I'm going to write this out. X plus H minus x minus h in parentheses? It's 2h. Okay, now that makes sense that the change in x is 2h because it's h above and h below. So the gap being 2h's is logical. This is 2h. Actually, I'll just write in the next step. That's 2h. So then the question is, when you take the limit of that slope to get the 2 points close together, what limit? How do you move stuff to get the points close? H to 0. H to 0. So in that respect, it's like the first one. Now, this is actually, I don't know that I haven't figured out how the inspire is defined. But I can tell you the 84 was programmed with the symmetric definition, and because of that, it actually gave you wrong answers once in a while. We'll talk about that later once you get into this. All right, you with me so far? Now, I need you to be able to do two things, really. Be able to use them to find your own derivative, and be able to recognize them when they're set up for you. So let's go with that first skill. If I said use the first definition to find f prime at 1, given that f of x is 2 minus x squared. This first definition at 1, that means obviously I'm going to use that single h idea of the point and that h away from it. And is this going to be at any old x or a specific point? Specific point in this case, a is 1, okay? A equals 1 here. So, can you set up the derivative for me? The limit as something. Does it help to say what are the points going to be, or does that not? Okay, so let's talk about what the points are. We got to do that. Okay, so the points. Surely 1 is going to be a point, because that's what they're asking about. You could go ahead and start finding f at 1, or you could just call it f at 1. I just call it f at 1, and I'll deal with what it comes out to later. Now the hard part, obviously, is what's the other? 1 plus h. Beautiful. 1 plus h. Great. F at 1 plus h. All right. So I actually, although you write the limit comes first in the statement, I actually write the slope first, and then I stick the limit on after. So what's the slope? F at 1 plus h minus f at 1, that's change in y. Change in the function is change in y over h. And what's the limit? H goes to 0. Beautiful. All right. So now we start to get into details. What do I do from there? All right, great. Now what? You plug in. You use the function. All right? So the limit as h goes to 0. And you say, what is f of 1 plus h? Well, f, the more complicated the function, the more I do kind of write the shell and then plug in. Wouldn't you say that the function generally says 2 minus whatever you put in squared? All right? So, and I'm going to actually do that twice. 2 minus whatever you put in squared, because I have two function statements there. The first thing I put in is 1 plus h, yeah? And in the second expression, the thing I put in is 1. And it's still over h. Some of the hard part for students starting out is, the function and what do you plug into what and all that stuff. So if that's an issue, you're just doing the normal starting struggles. Don't worry, just keep persevering. So when I distribute, kind of depends, the algebra depends on you and how, the fundamental rule is how quickly can you do it without screwing it up. So I tend to screw stuff up a lot, so I go a little slower. When I square 1 plus h, I get 1 plus 2h plus h squared minus, and then this I can just calculate. Wouldn't you say that that's going to be 1? Yes? Okay. Let's do a little cleanup. How does the numerator clean up? H squared plus 2h over h. We? Then what? Divide an h out of each term, leaving you with h plus, oh, wait a second here. Do I have a sign error going on here? Shouldn't these both be negative?
Yeah.
Okay, sorry. These are negative, right? Because we got a distributed negative? Sorry. Now, when I divide out an h, I'm left with negative h minus 2, yeah? Or negative 2 minus h, however you chose to write it. As h goes to 0 then, negative 2. Okay, I'm going to continuously go with the, does that make sense, does that make sense? This is not part of the problem, but just to check, does that make sense? What does that graph look like? Parabola opening, shifted up. It looks like this, yes? If I were to draw a slope, remember, derivatives are tangent slopes. If I were to draw a slope at 1, man, I gotta calibrate this. That's off, like that. Does that slope look like negative 2? Yeah, it seems like it's right on, okay? Okay, so let's move on to the second idea. Let's practice using the alternate definition. Now you can see that it's the same function, same question, so it should be the same answer. I'm just doing this by virtue of seeing how they compare. The first definition with a number in it and the alternate definition work to do the same thing. They find the slope at a particular point. I just want to do a little comparison with these, okay? So, would you, first of all, identify that in the alternate definition, if you look above what the alternate definition needs to head towards, the idea is that you're finding it at a certain point, 1, f at 1, and in the alternate definition, what's the other point you use? It's not the going h over thing anymore. It's just some random point x, f of x. Set up the slope or the difference quotient. What is it? F of x minus f at 1 over x minus 1. And the limit, how do you get the points close together? X, take x to 1. All right. Sounds good. Now, let's go with the functions. The limit as x goes to 1. What's f of x? 2 minus x squared. What's f at 1? Right, 2 minus 1. Way to go, me. X minus 1. The limit as x goes to 1 is distribute and simplify. What do you get in the numerator, my young friends? 2 minus x squared. 2 minus x squared minus 1, so 1 minus x squared. Yeah? You follow? Okay. Upon direct substitution, what do you get? 0 over 0. That stinks. Like all derivatives. Change in y goes to 0, change in x goes to 0. So that's to be expected. What algebra can I do? Factor. If I factor it the way it is, wouldn't this be 1 plus x, 1 minus x? And is x minus 1 the same as 1 minus x? You want to say yes, but are they really the same? No. So I have a little bit of an ordering problem. What can I do to solve that problem? Factor out a negative. All right. So if you take out a negative 1, then it would switch the order and make it factor the way we want it to, which is x minus 1, x plus 1. Then the x minus 1 divides away, and then I can evaluate the limit. If you put in 1, what do you get? Negative 2. And obviously that verifies what we just said. How'd that go? Okay. Man, it just occurred to me, you guys really fill up the seats way more than those little kids do. The room feels full when you guys are here. When the seventh graders are here, it's like it's almost empty. All right, you guys are ginormous. Here we go. This thing needs to be, excuse me 1 minute, this thing is making crazy. Sorry, my pen is off, and it's making crazy. All right. Okay. So, here we go. Using the first definition to find this cube derivative. Is this going okay? Are you with me? How did the homework go last night, finding the first definition derivatives? Pretty good or not so good? Okay, let's see. Number 3. What are the points? X and f of x. And if it's the first definition, what's the other point? X plus h, f of x plus h. What's the difference quotient? Over h. What's the limit? H goes to 0. Beautiful. Okay, so that is the definition of the derivative. Now specifics. The limit as h goes to 0. This time the function is cube plus 1. So that's x plus h all cubed plus 1 minus x cubed plus 1. H. I want to give you this one. No problem. All right, please somebody tell me no, you know the binomial expansion of a cube. All right, in the interest of time, x cubed plus 3x squared h plus 3xh squared plus h cubed. I got you. Plus 1 minus x cubed minus 1 over h. Knowing those binomial expansions is not a huge issue for calculus. Although if you're going to be a math teacher, you better get to know that. All right, how does the numerator simplify? X cubes go away. Okay, so I hear you say h cubed, I agree, plus 3x squared h plus, okay, 0, 0, what do you do? Factor out an h. So I get h squared plus 3x squared plus 3xh, right? Okay, so as h goes to 0, I'm left with 3x. So f prime, did I find f prime in a number or f prime at some x? Some x. F prime of x, or the derivative, is x squared. Okay. That is, again, what we did yesterday, so it should look familiar. Compare and contrast to the symmetric definition for the same question. Now, the symmetric definition, again, uses points on either side of x and brings them both close together from a symmetric or both sides approach. What are the points in symmetric? X plus h, f of x plus h for the point above, and x minus h, f of x minus h for the point exactly the same amount below. The difference quotient then is f of x plus h minus x minus h over a little bit different here, 2h. It's h above and h below, so that's a total difference of 2h and x. Limit as h goes to 0. H is the gap. I take the gap down to 0. Gets a little long. Symmetric takes the most horizontal room. But this would be x plus h cubed plus 1 and x minus h cubed plus 1, right? Here's where it starts to get long, and then it'll start to simplify. All right. So, we already know what x plus h cubed is. It is x cubed plus 3x squared h plus 3xh squared plus h cubed, and then the 1 would come along. Make sure you use parentheses on these problems and distribute the negative. On the x minus h cubed, it goes x cubed minus 3x squared h plus, I think, boy, I wish I would have reviewed this. 3x h, is this kind of, yeah, plus 3x h squared minus h cubed plus 1. Follow? If you had enough time, you could go off to the side and expand the cube, but that's not something we need to do right now with our time. All right, so here we go. Let's talk about what dumps out. What happens to the x cubes? They go bye-bye. X cubed minus x cubed will go bye-bye. What happens to the x squared h's? Let's just go in order. Do they go away or total up to more? 4. 6x squared h. Got those taken care of. What about 3xh squared? They go bye-bye. Okay, these do subtract away. What about h cubed minus h cubed? Minus negative h cubed. Add to 2h cubed. And 1 minus 1? Bye-bye. Okay, all over 2h. Let's simplify. Here we can actually divide out a 2 and an h. For example, if I were to factor in the top 2h out, what's left? 3x squared plus h squared over 2h. When you divide that out and take h to 0, you get the derivative is 3x squared. We. Okay, so there's an example in your notes of how to use each of the definitions of the derivative. Now, let's talk about recognizing. These are very common AP multiple choice questions. I don't have multiple choices for obviously, but it's important that you recognize a derivative when you see it. What's being given to you, being able to decode it. All right, so when you go to look at this, I might first start by looking at, is it x going to a constant? If it's x going to a constant, then it's probably an alternate definition, all right, where you have some numerical value and some x point by, and you bring them close together. So I'm thinking, looking at this, that's probably alternate definition. I also asked you to tell me, what's the function for this problem? What's the function? F of x is? What do you see going on? Now remember, the top is what tells you the function. The function must be absolute value of x, okay? And at what point? Are you finding f prime at any old x or at a specific point here? Are you finding the slope? What are you finding the slope at? At 3. You're finding f prime 3. Those are the three things I want you to tell me. What definition is being used? What's the function being used? And is it at a number or is it at an x? Okay. Take a look at the next one. Think it over.
Can you go over again how you got the absolute value of that right there?
Yeah. I know that in the definition of the derivative, at least in the alternate definition, this is the slope calculation. Now the bottom really doesn't tell me much because it's always just x. The function comes from, to find the function, look at the top. F of x is right here, and that's how I said, oh, it's absolute value. F of x minus f of c is absolute value of x minus absolute value of 3. That tells me then that f of x must be that, and the c must be 3. Okay? So just look at what's going on in the numerator to decide what's the function. Have you had a chance to think of B? Alternate first definition or symmetric? Alternate definition. What's the function? 2 absolute value of x minus 1. And at a point or somewhere else? At 3. You could say at 3 to answer the question, the third question, or you could say at prime and 3 is fine either way. Okay? Take a look at the next one. Which definition do you feel like? Okay, if it's symmetric, you see H's, so I see what you're saying. Is it symmetric? How can you, what's the best place to look for symmetric? Bottom, yeah. No, because not 2H, so it's not symmetric. The first definition, okay. So the first definition, what's the function? X cubed plus 3x. Okay. Now, remember your definitions. The first definition looks like this, right? So although x plus h is a good place to look for the function, the best place is to look right there, x cubed plus 3x. There's the function. Okay? And at a point or in any x? At any x. So that's at prime at all x. Okay? Try the next one. Talk to me, people. Which definition? Symmetric. What's the function? X cubed plus 3x. And at a point or at any x? Any x. Okay. Next one. This one. Gosh, you got an H there, so that's something. It's not 2H in the bottom, so probably first definition. Okay. What's the function? X to the x cubed plus 3x, and f prime at 4. They're throwing 4's in here because they're looking at 4. Okay. Look at the next one. Go ahead and think out loud. Which definition? Okay, first definition. F at x. Now this is kind of kooking me out right there. What the heck is going on? So if that kooks you out, maybe you should just ignore it and look at the first part. Because the first part's right. X cubed plus 3x. What at what point? X equal 4. Now, whether you know it or not, this is exactly the same as e. What's the difference? Yeah, I just totaled that up. Okay. Now sometimes that will happen in multiple choices. You'll look at some part and it'll just be cleaned up for you. Now, normally that'd be great, cleaned up, super, but actually it makes it harder when it's cleaned up. So you probably don't want to focus too much on that. Focus on this, and then if you want to make sense of that, to me this means, oh, this just must be the function at that number and cleaned up, and that can help. Okay. Look at the last one. This one's a bit of a trick. Now, because you're seeing x going to 0 and x there, it's tempting to think alternate definition. Of course, you would be wrong. That's not the alternate definition. I apologize. It's really not about the actual letter I put in there. It's about the idea I put in there. And this is just like that. The only difference is x instead of h. Now, why would you mess with me like that, Mr. Rick? Well, the reason is if you were to put this into your calculator, it doesn't really do h. And so you kind of have to be that, okay, I'm going to use x in place of h because my calculator wants it that way, but in my mind, it's really x is h, okay? The answer is no. This is first definition, just using x instead of h. It's arbitrary, really, anyway, and it's really for calculator purposes. Now, with calculator purpose in mind, last thing I need to do, catch calculator, please. If you don't have a calculator, I have a few up here, and if those get taken in goners, then you probably need to borrow looks on somebody else's. Okay. So, before I get to the calculator part, what does that thing mean in calculus? It's a definition of the derivative, I'll say that. Which one? This looks like a function, yeah? This looks like the function at, or something at a number. And this is x minus a number, yeah? So what is f of x minus f of a over x minus a? X going to a. Alternate definition. Alternate definition. What is f of x? What's the function? Sine of x. Where should I look? Right there. Okay? What's a? Pi over 6. Okay? Look here. And so you're looking for f prime at pi over 6, really. Here's the sine curve. Here's pi over 2. So pi over 6 would be here. All right? You're looking for that slope. Now, there is really no algebra to do here. You can't do any canceling or factoring, and so you're really out of luck. So that's where the calculator is going to come in. Now, the calculator doesn't know calculus. Let's make this very clear. The calculator only does add, subtract, multiply, and divide, and everything else it does is just algorithms to use those 4 functions. That's the 4 things it can do. When it takes sine and cosine and everything else, those are just Calc 2 formulas for how to do that. Now then, our calculator, we're just going to ask it to calculate a slope. The calculator is going to find 2 points. Now, Inspire, I think it finds 2 points within 100,000th of each other and calculates the slope. That's all there is to it. On the 84, I think it took 2 points within 1,000th of each other. But at any rate, the calculator is just, it's not a calculus master. It's just a darn good estimator, as Ms. Cannon always says. So would you please go to your calculator and let's take a little look at how do you put, now I could graph this and see what the graph approach is and do a limit in the table-y kind of way, but instead we're going to do the derivative in the calculator. Now if you have an Inspire, one way to do this in the Inspire is to go to Menu. Now I need to look at this. Menu? Do you see calculus when you hit that? Am I looking at the, oh, sorry, I need to look at this to do. Okay, go to Menu. Actually, start with the scratch pad or get a document going. Sorry, Menu. You can see calculus. Yay. Okay. So menu calculus, you want the numerical derivative at a point. So choose that option. And the variable is x in this case, so you're all good. In our problem, we saw x is the value. At what value do I want the derivative? Pi over 6. Okay, so give me a pi divided by 6. First derivative, you can take second, third derivatives. We'll talk about that later. Just hit OK. Now, it pastes this bad boy into your scratch pad or home screen. Now, what is it waiting for? The function. It's saying take the derivative of what? And we want to take the derivative of sine of x. Throw that in, and 0.866. Now, actually, I would need to make sure my calculator's in radians. Sine of 30. It is in radians. Okay, so if you got 0.866, then you are good. If you got something else, then you might be in degrees. So make sure that you are not that case. Did you get 0.8660? Spire menu, calculus, numerical derivative. Okay, and so we would say that this is 0.866. Always give me 3 or more decimals. Does anybody have an 84? Cool. Go to Math 8. When you do that, did it paste in a derivative expression kind of thing? Okay, so same deal then. So this you're going to do is then the function, then the value. Okay, type that in and see how it goes. Man, I'm going to have to take a day to catch up because I am so far behind. All right. Would you try this one, please? Find the instantaneous rate of change at t equals 6 for that function. What does instantaneous rate of change mean? Derivative, yes, indeed. I forgot what the function was. What was the function? 3t minus log base 4 of t. Menu, calculus, derivative. T, if you want, you can call this t. What did I say at? What value? At 6, at a value of 6. That's the number you want the slope at. Okay, now the function, what did I say the function was? 3t minus log base 4 of t. I wanted to see if you remembered how to do log, or if you ever knew. 3t minus, how do you do log base 4? I think it's in here, isn't it? No, it's not. Where is it? Control what? Oh, perfect. Beautiful. Oh, shucks. Just a second. Oh, no. Okay. No, never mind. Go away. How to... Oh, shoot. Sorry, I was... Okay, thank you. Oh, right. There you go. No, Oh, okay. Oh, everything is all breaking loose. Oh, my gosh. Log base something 4 of t. Boom. Did you get 2.8797? Yes. Okay. You can just use it. You don't even use t. You can just use it. It'll work just fine. Okay. Now then, that was, what was your answer again? 2.875? 59? 97. Okay. 9.497. Okay, we need to talk about decimals. I still haven't talked about that. Man, I'm behind. I need block schedules, really. What I need. You need an hour and a half of calculus to really. Okay, so here's the problem. Now we have 3 sets backed up. Yes? Oh, you don't even have the homework. Oh, do you have your homework?
Yeah.
Oh, yes. Okay. So I did put the key to the. I don't even remember what it was. What's the oldest thing you have? IVP? Could I get that by the end of the day because the key's there? Or no, you are so lost you need. I say yes. Okay. IVT due by the end of the day. Oh, cool. All right, for Pete's sake, but all right, I am going to put these online. You best look at them because I don't have a lot of time for questions. So start using those keys online. And I guess nothing's Tuesday.